All right, hello students and welcome to this session on integers where this is a one-shot session, so we would be revising all the concepts from this chapter in one shot. All right, so before we are starting off, quickly let me know if I am audible and visible. Come on, show me some thumbs ups here in the comments if you think I am audible and visible there. Okay, Shri Han says hi, hi. Arka says yes, okay. Pradnya Patel, hi sir, hi Pradnya. Happy translations. Okay, good evening. You are perfectly visible and audible. Awesome. So now that I am perfectly visible and audible, so come on, let's start the session off. And firstly, what I'd like to give you is a roadmap of how we are building on with all of the concepts, and then we shall start. All right, so come on. Okay, so we will start off with the first concept being Bodmas, the order of operations. I'm sure you know that. And then we will cover multiplication on the number line followed by multiplication without the number line. So these two concepts, 2 and 3, are going to revolve around, multiplying positive, negative integers and so on. And then we will check out division of integers and then check out all the properties, addition properties, subtraction properties, multiplication and division. So this is going to be a super simple session. Most of the students must have already seen the concept videos that were done earlier. In case some new students have joined, there's nothing to worry. You are going to follow each and every bit. And students have already seen this. Well, this is going to act like a good revision for you. All right. So come on, let's start off now. And before we do, make sure you guys hit the subscribe button in case you still haven't, so that you receive all the notifications and updates on time. Okay, so I hope you guys have subscribed. So come on, let's start now with the first session, with the first concept. Okay, so as I said, we're going to be starting off with Bodmas first. So you guys are familiar with this, right? It just simply tells you the order in which you should be picking these operations. So brackets stands B, and then of, and then division, multiplication, addition and subtraction. So this should be your priority, starting from brackets and then off, then division, multiplication, addition and subtraction. Now I am going to give you a question revolving around this, and then we will proceed on to the next concept. Okay, so have a look at this question. Now apparently this was the question which, according to some news articles, stumped the internet. The problem went viral because quite a lot of them weren't able to solve it. Let's see how many of you can solve this question. This is a fairly simple one. As long as you know the rules, you should get the correct answer. Come on. So try to work this out. Apply the order of operations, brackets, of, division, multiplication, addition and subtraction, and type your answers out there in the comments box. Okay, so I have the first answer from Anvi Mahajan 16, Arka says 16, Shaurya 16. Okay, pretty much all the answers are 16. Nagendra, Deepthi, Harsh, Yashasvi, Mahi, Santosh, Kumari. Okay, all the answers are 16. Let's see, let's check out if it is indeed 16. So first thing, what do I have to do? First thing that I have to do is look at the brackets. I simplify the brackets first. So I calculate the part which is inside the bracket. Now inside the bracket, what do I have here? 2 plus 2. So I'm going to simplify this. So now this will become 8 divided by 2 multiplied with, what is 2 plus 2 here? 4. Very good. Now what do? I pick up division, right? Because I'm done with brackets and now the thing left is division. So this becomes what? This becomes 2 multiplied with 4, right? So what do I do now? I pick this up. 8 divided by 2 is how much? 8 divided by 2 is 4, and 4 multiplied with 4, since this is quite the last operation left out, this is equal to 16. Now you have studied Bodmas. There are some textbooks which follow this, okay? It is called as PEMDAS. Now it is pretty much the same. It is parenthesis, exponent, multiplication, division, addition and subtraction. So here, if you're following, if some students, let's say, had followed this rule, then according to this rule, multiplication comes first. But we are following Bodmas, so division comes first. Now try and remember this. Both multiplication and division have an equal priority. Okay? But then, which one do we pick first? We pick one to the left. That's it. Whichever sign comes first, either it's division or multiplication, to the left, we pick that first. Okay, so students who were following this PEMDAS here must have got a different answer, and that's the reason why probably this question went viral. Okay, because people getting different answers for this. So we are good. We are done and we have got the correct answer for the 16. So that was all about Bodmas. You know, it simply tells you the order in which you should be picking out the operation, starting from bracket, then off, then division, multiplication, addition, and subtraction. Well done. So this was a super simple concept. Now let's move on to the next one, which is going to be multiplication on a number line. So come on, let's check out the second idea. Multiplication. Now, multiplication concept-wise, you all know that it is a fairly simple idea, right? Like, let's suppose I am adding 2 3 times. Now, addition-wise, well, I should be getting a 6, right? 2 plus 2 plus 2. But let's say I'm adding 2 100 times, then I don't want to be writing that, right? 2 plus 2 plus 2 plus 2 all the way 100 times. So we've devised a shortcut, and multiplication is nothing but the shortcut for addition. So repeated addition is multiplication. So how many times are we adding 2 here? 3 times. So I simply say 2 times 3. Now this simply tells me that I am adding 2 3 times, and what I get is the same answer, 6. Okay, now another example, 3 plus 3 plus 3 plus 3. How many times am I adding 3 here? How many times am I adding 3? I'm adding 3 4 times. So that's the reason why I write a 4 here. And 3 when added 4 times, that is 3 multiplied by 4 or 3 times 4, whichever way you want to go with it, is going to be equal to 12. So this is the simple idea of multiplication, which is nothing but repeated addition. And the reason why we do this, as I told you, I don't want to be writing 3 plus 3 plus 3. Let's say I'm adding 100 times, right? That will become quite lengthy. So a short way of writing that is 3 multiplied with 100. Okay, so that's pretty good. So this is the basic idea of multiplication. Then you had also learned multiplication on a number line, right? Now let me slide this guy around, and he's gonna do a slow slide from 0 to 6. You know, the same concept that we covered earlier. He's gonna do this 2 plus 2 plus 2, which we wrote it as 2 times 3, which was 6. So he came from 0 to 6. Now let's do the hopping. Okay, so here you have a frog. He's gonna hop 2 places 3 times. So that is another way of visualizing a multiplication on a number line. So hopping 2 places 3 times is going to take you to the answer, and that is 6. And obviously you're starting from 0 here. Okay, so this was multiplication on a number line. Now you've also dealt with negative integers, right? What were they? Well, you have positive integers. What are positive integers, guys? What are positive integers? 1, 2, 3, all the way. They go on and on and on. And then we also have negative integers. Negative integers are going to be what? -1, -2, -3, on and on and on. And you have to remember that 0 is an integer, but 0 is neither a positive integer nor a negative integer. 0 is a neutral integer. Okay, so this is the number line. You have positive integers to the right of 0, and you have negative integers to the left of 0. So what are you going to do when I ask you, let's say, -2 times 3? Well, when you have to do -2 multiplied with 3, just change the direction, okay? Move to the left. So you have to hop -2. -2 means what? Left 3 times. So same idea, okay? 1, 2, 3. And you arrive at the answer, which is equal to -6 here. Well done. I am getting answers from the students, Nagendra, Kanishka, Satya, Dibyanshi, Harsh, Yashasvi. Yes, all of you are coming up. Deepthi, again, coming up with the correct answer, -6. Well done. So this was multiplication on a number line, a fairly simple concept that you've covered before. Now, let's check out multiplication without the number line, okay, which was the third idea. Okay, so simple rules to be followed here. Nothing too fancy. Like, look, these 2 smileys here, same signs, positive. Okay, so when positive is multiplied with positive, the result is positive. And when negative is multiplied with negative, the result is positive again. Different signs, well, a sad face, right? So the result is going to be negative. So a negative multiplied with positive or a positive multiplied with negative is going to result in a negative answer. Okay, so look, positive multiplied with positive is positive. Negative multiplied with negative is positive. And basic absolute rules. Now let's go ahead and apply this to a few questions. Okay, let's bring this on now. So +5 multiplied with -6. First, don't worry about the signs, just multiply. So what is 5 multiplied with 6 going to be? Well, 5 multiplied with 6 is going to be 30, right? So I'd simply write the number down. Now focus on the signs. So one is positive, one is negative. Different signs. So well done. That's the reason why the answer is going to be minus 30. Very good. All are commenting out the correct answers. Well done. Now let's move on. Minus 5 multiplied with plus 6. Again, 5 multiplied with 6 we all know is 30. Now check out the signs. What are the signs? One is negative, the other is positive. Again, the signs are different. So we learnt it, right? Different signs, negative. Same signs, positive. So again, the answer is going to be negative 30. Very good. Now let's bring on. Okay, so this time what you have, 30 is going to be the answer for sure. But then one is negative, the other is negative. So both the numbers have the same sign. So negative multiplied with negative, the answer, very good, it's going to be plus 30. Well, very good, guys. And the last thing, 5 multiplied with plus 6. And when I simply write 5, it means plus 5. When you're writing 7, it means it is a positive number. You don't have to put a positive sign before that. When you've just written a 7, it means it is positive. But when I write minus 7, yes, it is a negative number. So this is going to be again plus 30 because both the numbers have a positive sign. So this was multiplication done without a number line. So I'm sure you guys have followed these three, right? First was Bodmas, then multiplication using the number line, hopping frog, yeah, and then this one was multiplication without the number line. Three absolutely basic ideas. Okay, Arka says, sir, what we will write, plus 30 or 30, please tell me. Okay, Arka, look, even if you write 30, it means it is positive. You don't have to write plus 30 every time. Okay, but then there may be some questions that will specify that for a positive number write the positive sign and for a negative number write a negative sign, then you have to. But generally when I simply write a 30, it means that the number is positive. Okay, very good. Now let's move on. Different signs. Okay, we've taken care of that. Now let's check out product of 3 or more negative integers. Okay, come on, let's check this out. First thing, let's do this. What is minus 4 multiplied with minus 3 going to be? Minus 4 multiplied with minus 3. First, let's not worry too much about the signs. Let's worry about the numbers. So I have 4 and I have 3. We all know this. 4 multiplied with 3, the result is going to be 12. Okay, I've taken care of that. And now if you look at this, both the numbers have the same sign. So same sign means what? Positive. So minus 4 multiplied with minus 3, the answer that I am going to get is 12, or as you said, you know, just plus 12. All right. Now, what is the answer going to be? This is interesting because we've already calculated this, right? We've already calculated the answer to this, and the answer was how much? Plus 12. Minus 4 multiplied with minus 3 was plus 12. Now, multiply these two, right? Again, don't worry about the signs first, just do the multiplication. So 2 multiplied with 12, the answer is going to be 24. That was simple. And now focus on the signs. Look, one is negative and the other is positive. So different signs means I will put a negative thing here. That's it, right? Very simple, very good. All of you are giving the correct answers here. Let me just rub this part out. Okay, now you have seen that we have done the multiplication for these three right here. And what was the answer there? The answer that we got was minus 24. Awesome. So now it simply boils down to multiplying these two, right? Minus 1 multiplied with minus 24. Forget about the signs first, just focus on the numbers. So 1 multiplied with 24 is going to be 24. Now focus on the signs. Both the numbers have the same sign. So same sign means what? Positive. So the answer is going to be plus 24. So I hope this was very, very simple, right? Let me just take one more example. Let's say you have minus 3 multiplied with minus 7 multiplied with 5. What would the answer to this be? Just pick two numbers at a time and figure out the answer. So first we can pick these two. Whichever order we do, it doesn't really matter. You know, that is one of the rules that is coming up later on. So minus 3 multiplied with minus 7. Okay, Harsh already has the answer to this, 105. Dibyanshi also has the answer, 105. Nagendra has it now. Shaurya, well done. Happy translations. Okay, Dibyanshi again. Kiran Kumar also has the same answer. Anvi, 105. Well done, guys. Satya has the same thing. Deepthi, Kanishka, awesome. Cool. So this is going to be what? Plus 21, right? Because 3 multiplied with 7 is 21. Negative multiplied with negative is positive. And now all you have to do is plus 21 multiplied with plus 5. The answer is going to be, very good, 105. So now we can safely move forward. I assume you guys have understood this. Awesome. Let's move on now. Okay, so now we move on to the fourth concept for the day. We've already covered Bodmas, multiplication on a number line and without the number line. So now let's check out division of integers. Okay, let's take a basic example. Now look at this here. How many apples do you see? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, let me write that down. So I have 12 apples. And how many people do you see here? 1, 2 and 3. So there are 3 people. So these 12 apples have to be divided or distributed among these 3 people. So when I do that, each person is going to get how many apples? That's the purpose of division. You divide or you distribute. Let's see graphically how that's possible. So you see, each guy here is going to get 4 apples, right? Let's check this out now. So first, let's check out division as repeated subtraction. By the way, I'm sure you guys know how to divide, right? These 12 apples, okay, when I'm dividing it among 3, you all know each person is going to get 4 because we are familiar with this division. 12 when you divide it by 3, 3 times 4, 12, and the remainder is 0. Remainder 0 means there will be no apple left out, right? So that's the reason why each person here is getting 4 apples. Awesome, very good. Now, this concept is also quite familiar, right? Like treating division as repeated multiplication. Let's see how that is possible here. So we started off with 12 apples. Why am I subtracting 3 here? Because I'm trying to divide it among 3 people, okay? And I will keep subtracting. So first, from 12 apples, I'm subtracting 3. How many apples are left out? 9. So this is what is happening, guys, here, okay? Let me just draw this out here. Okay, let's say these are the 3 people. I'm treating them as boxes here, so that it's easy for me to explain you. So first thing, what I'm going to do, this division as repeated subtraction means is a simple thing. First, I will give each person one apple each, okay? He will have 1, he will have 1, and he will have 1. So from 12, I have given 1 apple to each of the 3 persons here, and now I am left with 1, 2, 3. These 3 I have given them. So I'm now left with 9 apples, so that's why 9. Again, I will repeat the same process. I will give them each 1, 1, 1 and 1. So again, 6 apples are left out. And again, I repeat the same process. I give 1 to each. 1, 1, 1. Again, 3 apples are left out, and then I'm going to again give 1 to each. And now when I do that, no apples are left out, which means, as you can see, each of the person here is going to get 4 apples. So this is how we can treat division as the idea of repeated subtraction. Okay? Come on. Now let's move on and check out the change in signs. Now division here is going to be absolutely similar to multiplications. The rules do not change. Okay, same signs. Again, a smiley face, positive, and different signs. Well, it looks like somebody has given the person a black eye here. Okay, so different signs here is going to mean negative. So just remember this, same signs, positive, different signs, negative, and the rules are pretty much the same. So positive divided by positive is positive, negative divided by negative is positive, positive divided by negative or negative divided by positive, as you can see, is going to be negative. Okay, very good. Satya also has summarized same as multiplication. Kanishka says, okay, sir, thank you. Awesome. Let's move on now and apply this out to some questions. So look, again, don't worry about the sign first. Just take care of the division. So 8, when I divide by 2, how much do I get? 4. I've written 4. Now check out the signs. So positive divided by negative. Different signs. That's it. Just put the negative number. That's it. As simple as that. Okay. Again, 8 divided by 2. We've taken the same example. So pretty much in all of the cases, you are going to get 4. Right. Now let's worry about the sign. So minus, plus, different. So that's the reason why I write minus. Very good. I am getting the correct answers from all the students out there. Okay. So third one is going to be what? You divide negative with negative. So same signs. That's the reason why positive. And again, positive divided by positive is going to be positive again. Very good. So multiplication and division, the rules are pretty much the same with respect to the sign. So same signs means positive, different signs is going to mean negative. Okay, so I hope all of the concepts and examples that we've taken so far were well understood by all of you. Yes, so come on, let's move on now and check out what we have next. All right, so I believe we are done with our division of integers, and now we are ready to have a look at additive properties. Okay, now before we move on to the additive properties, I have an amazing fun fact for you. Now, how many are familiar with the Bluetooth? I'm sure you guys have used it, right? Bluetooth. Come on, go ahead and type that out in the comments box. How have you used the Bluetooth? Bluetooth. Come on, I'm sure you guys are familiar. Yes, Pramod says I am familiar. How have you used Bluetooth? How do you use the Bluetooth technology? I mean, it's available on each and every smartphone, laptops, and all of that, right? Yes. Satya says headphones. So Bluetooth for online classes. Yes, you can connect a phone with a wireless earphone. Let's say you have it using the technology of Bluetooth, right? So it's a fairly useful technology, but how many of you can tell me how did that name Bluetooth come into the picture? Why only name it Bluetooth? You know, why not some other name? Why did they only call it Bluetooth? Yes, you also connect the speakers, wireless speakers. Sriharan says for listening music with headphones. Yes, transferring files, very good, transferring files. But why did they only name it Bluetooth? Well, it was named after a king, okay? The king's name was Harold Bluetooth, okay? Now, another question should be, why did they name it after a king? What was the purpose? Well, this was a king who united two countries, okay? He united Denmark and Norway. So the king named Bluetooth united two countries, Denmark and Norway, and our Bluetooth these days, well, they do the simple job of uniting your phone with the headphone or the phone with the camera. Okay, so I just read about it today, and I wanted you to share this with you guys as well. So now you won't forget the origin of the word Bluetooth there. All right, awesome. So come on, let's move on now and check out the properties. So first thing that we're going to do here is check out the properties related to addition. So awesome, cool. Let's check out the property of closure. All right, so you guys are familiar with the property of closure, right? Yeah. Satya says connecting. Okay, KFS says earphones. All right, so we've seen that the king united Denmark and Norway. All right, now let's get back to these properties. And the property is, first, property of closure. This is a simple property, right? What does this property tell us? Well, this property tells us a simple thing, that when you pick two integers, any two, it can be positive, one negative, both positive, or both negative, doesn't matter. When you pick two integers, let's say I1 is the first integer and I2 is the second integer, and when you add them, the result is always going to be an integer, right? Take any example, like let's say you're taking -3 plus 5. The result is going to be 2, which is an integer. Let's say you take both negative, -2 minus 3. The result is going to be -5, which is again an integer. So that's the reason why we say addition follows property of closure, because when you pick any two integers and add them, the result is always going to be an integer. Okay, so this is the property of closure. Integer plus integer is equal to another integer. So that's the reason why we say addition follows closure property. Fairly simple. Come on, let's move on now. Sushma, okay, there is a doubt. Sir, I have a doubt that in integer word problems, we always take money owned positive and money deducted negative, or when we have to find whether it's a gain or a loss. Okay, that's a very valid question, Sushma, and I'm going to spend a little bit of time on that. There's a reason why we do it, okay? Let's say you have a bank account. Well, you're going to take simple numbers here, okay? Let's say your bank account, you have 100 rupees here, okay? And your parents give you pocket money, all right? Now, let's suppose your parents have given you 100 rupees on Monday, let's say. So 100 rupees will get added to your bank account, right? So now, since your bank account initially had 100 rupees and your parents have added 100 more to your bank account, now your bank is going to have how much? 200 rupees, right? Very good. And let's say you go to a shop, you like something, but that costs you 300 rupees. Okay, can you buy it? Well, of course you can't, because your bank account, you only have 200 rupees and the item costs you 300 rupees. But let's say, your bank decides to loan the money out to you. All right. So now what is going to happen is you owe the bank, because you've purchased it. Let's say you've purchased that item of 300. You've paid 200 and now you owe the bank 100 because that bank gave you that as a loan, right? So that's the reason why now your bank balance is going to show minus 100. So that's the reason why minus 100 is used to show a loan maybe that you owe to someone. Now what will happen? Let's say your parents gave you 100 rupees pocket money on a Tuesday again. Now what will happen is your bank balance will show 0. Right? Because you owed 100 rupees to the bank. So the moment your parents gave you 100 rupees on Tuesday, the bank will collect that. Now I'm making things simple here. I'm not including the notion of interest rates and all of that here. So that's the reason why that was a valid doubt. All right, why negative numbers are assigned some way and positive numbers are assigned in another way. You could also take example of temperatures, right? They are more relatable for you in case loan and all is not. The positive and then very cold, negative temperatures, right? I hope that is clear now, Sushmita, right? So I'm going to move on now. So, right, so that was closure, fairly simple. Now, let's understand the property of commutativity, a fairly simple idea again, because it simply tells you the order in which you add doesn't matter, because even if you add 4 plus 3 or 3 plus 4, the answer in both the cases is going to be the same, right? 7. So how do we generalize this? We generalize it like this, like A plus B is going to be equal to B plus A, assuming that A and B are some integers, all right? So this is going to apply, right? The property of commutativity. Well done. This was a simple one any which ways. So let's move on now. Property of associativity. Associativity, it's easy to remember. Associations, right? Associations means what? Togetherness. So that's the reason why you're keeping numbers inside the bracket, which means they are together, right? So this one, left hand side is what? 4 plus 3 inside the bracket and the plus 6 is outside. Yeah, so what two numbers am I associating together? 4 and 3. But then the association could be something else as well. Like you can put 3 plus 6 inside the bracket and keep the 4 out. Eventually your answers is going to be the same, right? Like 4 plus 3 plus 6. How would you evaluate this? Bracket first, don't forget the Bodmas. 4 plus 3 is 7. So this is be 7 plus 6. The answer will be 13. Or, doesn't matter, even the other way. 4 plus 3 plus 6. Now you would evaluate 3 plus 6 first. This will be 9. 4 plus 9. Again, the answer is going to be 13. So this is a simple, property of associativity. All right, so I have some interesting comments out there. Deepthi says altitude measurements are also examples. Yes, Deepthi, you are absolutely right. They are. Sriharan, why do we take withdraw as positives and deposit? Well, withdraw as positive, deposit as a negative. I think you're taking the other way around. Withdraw would be considered negative because let's say you have 1,000 rupees and you have withdrawn 200, okay, which means you have, withdraw means what? Remove. Remove is subtraction, right? So now your bank balance would be 800. Yeah, deposit would be positive because let's say somebody deposited 300 in your bank account, that would be considered positive. Okay, so now since there were 800, somebody deposited 300, your bank balance will show a good 1,100 rupees. Okay, Pramod has also summarized the property of associativity. I'm sure this is clear. Sriharan, doubt is also clear. Withdraw would be negative and deposit would be positive. Okay, cool. Let's move on now. Identity property. This was again a fairly simple one, right? Additive identity means what? When you add nothing to a number, the result is going to be the number itself, because what have you added? You've added nothing, right? 0 is indeed nothing, right? Cool. So A plus 0 is going to be equal to A. Withdraw means removing money. Yes, Sashmita, you are right. And that's the reason why that is treated as negative. Removing means subtraction. From 10, you remove or subtract 6. The result is 4. That's the reason why removing is considered negative. Okay, so this was simple again. As I said, you add nothing to a number, the result is the same number because A, you've added nothing to it, which means 0. That's the reason why the answer is going to be A. Very good. This was a simple one. So those were your simple properties around addition, closure, commutative property, property of association or associativity, and then the additive identity. Okay, now let's move on from addition to subtraction, and let's understand subtractive properties. Okay, so first thing, let's try and understand if subtraction follows closure or not. How many of you say subtraction follows closure? Yes, I think subtraction will follow closure, right? Because from one integer, I remove another integer, the result is going to be an integer, right? It's not going to be a fraction or a decimal or something, right? So that's the reason why subtraction follows property of closure. An example could be what? Let's say from 10, I am removing 7. The answer is 3. So from one integer, if I'm subtracting another integer, the result is going to be an integer. It won't be a fraction or a decimal, right? It would be an integer. That's the reason why subtraction follows closure. Moving on. Does subtraction follow property of commutativity? No, it doesn't, because A minus B is not equal to B minus A. Plug in some numbers and you'd understand. Like example here says what? 4 minus 3 is not equal to 3 minus 4. Because what is 4 minus 3? 1. 3 minus 4? Minus 1. And we know 1 is not equal to minus 1. So that's the reason why subtraction does not follow commutativity. Now let's check out, does subtraction follow associativity? Of course, no again, because you can't just combine numbers like you can with addition, changing the brackets. Because have a look at this example. The left hand side and the right hand side are not going to match. Harsh says, sir, please give us a question to solve. Okay, I'm going to give you a question now. Let's say 10 minus 3 minus 7. Now do it this way. 10 minus 3 minus 7. Do you think the answer is going to be the same here? What do you guys think? What do you think? The answer is going to be the same? I've given you a question, Harsh. Gargi says it cannot be subtracted in any order. Yes, the answer is not going to be the same. This is a perfect example for that, right? Because look, 10 minus 3 is 7. 7 minus 7, the answer is coming as 0 here. And this is going to be what? 10 minus 3 minus 7 is going to be how much? Minus 4. Minus of minus, you've just seen that it will make a plus. And as you can see here, this is becoming 14. And we know 0 is not equal to 14. So this is a good example of subtraction not following the property of associativity. Okay, so all fairly simple rules. Again, let's move on to another property. And this time it is going to be multiplication. So this one should be a fairly simple one. Let's go ahead and check that out. Okay, does multiplication follow property of closure? Of course it does, because when you multiply two integers, the result is going to be another integer. Generalize it. First integer, when you multiply it with another integer, the result is going to be an integer. As you can see, 4 multiplied with 3 is 12. And 12 we know is an integer. This will apply to the negative integers as well, right? Like minus 3, when you multiply it with plus 5, the result, as we've seen, we've solved plenty of questions based on that. The result is going to be what? Minus 15, which is an integer. So that's the reason why property of closure, multiplication obeys that. Okay, very good. Yes is what all of you are saying. Now, the property of commutativity. Now, like addition, multiplication also follows the property of commutativity, because A multiplied with B is going to be equal to B multiplied with A. Take any example, like here, 4 multiplied with 3 is going to be 3 multiplied with 4, right? Deepthi says, I have some confusion in distributive property. I'm coming to that, Deepthi. Okay, I am coming to that next. Okay, now property of associativity, again, multiplication follows this. Now so far, if in case you just want to remember it, look, addition and multiplication are going along together, right? All the property that addition follows, multiplication is also following it so far. As you can see, again, if I change the brackets, it won't affect the answer. 4 multiplied with 3 is 12. 12 multiplied with 7, answer is going to be 84. Again, you do it this way. 7 times 3, 21. 21 multiplied with 4, answer is going to be the same, 84. So multiplication follows property of associativity. Very good. Let's move on to the next. Okay, you remember additive identity? Additive identity, if I ask you, what will you say now? 0 is the additive identity, because additive identity is not going to change the number. Okay, like A, when you add 0, it remains the same. It does not change. In a similar way, multiplicative identity is not 0, it is 1. Because when you multiply a number by 1, it does not change. Okay, the number remains the same. So remember this. What is additive identity? 0 is the additive identity because it does not change the number. And what is a multiplicative identity? 1 is the multiplicative identity. Again, for the same reason, it will not change the number. Very good. Awesome. Let's move on now. But then you know this, right? Any number, when you multiply it with 0, the result is going to be 0. I need not spend too much time here. I'm going to get to the doubt that Deepthi had regarding property of distributivity. So let's spend a little bit of time here in understanding what distributive property is. Okay, now this is all about opening up the brackets, guys. That's it. Like, let's suppose I give you an example. Let's say 2 when you multiply it with 3 plus 5. Okay, now how can you solve it? If you are thinking about solving it using Bodmas, then which operation will you do first? You will try to figure out what is inside the bracket first, right? How will you do this? Well, this will be 2 multiplied with 3 plus 5 is inside the bracket, so you know is 8. So 2 multiplied with 8, you will know that the answer is 16. Fairly simple, you know. I wouldn't say you're wrong if you do it this way. Perfectly fine. You've applied Bodmas, order of operations, simplified brackets, and got the answer. Property of distributivity tells you that you can remove the brackets in a different way. Like, you can multiply these two first because there is multiplication here. So this can be written like 2 multiplied with 3. So this 2 will get multiplied with 3. Now there is plus. So I will write a plus, and the same 2 will get multiplied to the next number inside the bracket, and this will be 2 multiplied with 5. And as you can see, you are getting the same answer. So that's the reason why we say distributive property holds true for multiplication over addition and subtraction. Over addition and subtraction, I'm explaining you that now. First, multiplication is here, multiplication is here. Over addition and subtraction means these signs are inside the bracket, okay? Over addition means addition is inside the bracket, and over subtraction, subtraction is inside the bracket. I'm sure this is simple now. Let's take a case of subtraction now. Let's just rub this off since you guys have already understood it, I'm sure. Now let's take this, 3 multiplied with 7 minus 4. Let's say, you can figure this out without opening up the bracket like this. Like this is 3 multiplied with 3, which is 9. Or you can simplify it in another way. So 3 multiplied with 7, 21, minus 3 multiplied with 4, 12, and again you get the same answer, 9, right? Now, a question that should pop up should be, why? Why am I learning it this way? You know, when brackets can simplify it for me, why do I have to, understand this property of distributivity? Well, this is a simpler method in case the numbers inside the brackets, you know them, okay? But as you will see, as you move on and, get to algebra, which is, the art of figuring out the unknown, sometimes numbers are not known. And sometimes you may get something like this, 3 multiplied with a minus 5. Now, in this case, you can't simplify the bracket, right? Because a is unknown. You don't know a. So what you need to know now is, hey, I did something called property of distributivity, and using that I can open this up and simplify this. Simplify this, that's it. So this can be written like what? 3 multiplied with a minus, and then the same 3 multiplied with 5, right? And now this can be written like 3 multiplied with a. In math, we simply write it like 3a minus 15. So you see, this is the reason why you are studying the property of distributivity, because numbers inside the bracket may not always be numbers. Sometimes you may have unknown variables as well. Okay, yes, Satya says in algebra we use distributive property a lot. Yes, especially when you want to solve equations, figure out the value, this comes in very, very handy. So that's the reason why I want you guys to master it now itself. Like, let's put all the 3 variables. Okay, the same rule will apply. Let's say you have a multiplied with b plus c is inside the bracket. So using distributivity, how would you write it? A multiplied with b, okay, and then the plus sign, and then the same a multiplied with c. That's it. Okay, this is all you've got to know about this. Okay, Sushma says, could you please explain this? Question, I believe, okay. A class of 36 students contributed 2,540 each for the picnic. Out of these, 7 students decided not to go. They were returned 490 each. What amount was spent on the picnic? Okay, first thing, look, I'm going to give you a direction on that. First thing is, let's break the problem step by step, okay? 36 students contributed 2,540 each for the picnic, right? So each student gave how much money? 2,540, which means how much money was collected? The total money that was collected is 36 multiplied with 2,540, right? This much amount was collected. Now I'm not gonna multiply this. You do it better than me. So I'm just gonna give you a direction here. So this was the total amount collected. Awesome. Now out of these, 7 students decided not to go. They were returned 490 each. Okay, so 7 students decided that they don't want to go now, but they did not get the whole money back. They only got 490 rupees each, right? So how much money was returned? How much money was returned? 7 multiplied with 490. I'm sure you guys understand why I'm multiplying, repeated addition. Each student 490. So 490 plus 490 plus 490 plus 490 7 times is going to be what? 7 multiplied with 490. What amount was spent on the picnic? Let's say you get some answer A here, okay? And then you get some answer B here. The amount spent on the picnic is going to be what? A minus B. The total amount collected, from that you will remove the amount that was returned back to the 7 students. This is how you can simply solve it, okay? Harsh, it's not going to be 29 divided. I think the question was each student paid 2,540. Okay, so that's the reason why you will multiply. Like let's say 3 students, okay, each paid 2,540. Then how much money was collected? 2,540 plus 2,540 plus 2,540. So how would you say that? 3 multiplied with 2,540. That's the reason why, since it was collected from 36 students, when you add 2,540 36 times, you get 36 multiplied, because that's the trick you guys have to develop. When I say you should understand multiplication and division conceptually, what I mean is, when I give you a worded problem like one of our friends gave us today, you should be able to understand where I need to multiply and where I need to divide. That's the whole task, okay? You need to be able to read it and then decide where should I be multiplying, where I should be dividing. Division will work like this. Let's suppose I have 10,000 rupees, okay? I want to divide it or distribute it equally among 10 people. Then you will divide, all right? But let's say each student paid 200 rupees and there are 10 students in the class, then you will multiply, because 200 plus 200 plus 200, think it that way, okay? Very good. So I'm sure you've understood the process. I couldn't multiply these and give you accurate answers, but I'm sure, as I said, multiplication is something you guys would do it far better than me. Okay, so moving on now, distributivity is done as well. What is the next thing that we are covering? Well, the last would be properties of division, and we'll be done after that. Okay, so closure doesn't apply to division. You see, closure applies to all of it. It applies to addition, subtraction, multiplication, but closure doesn't apply to division. Why? Because check this out. In some cases, like 10, when I divide by 2, the result is 5. So one integer divided by other integer, I am getting an integer here. But it doesn't work out every single time, because let's say you have 10 divided by 4. This is equal to how much? 2.5. You are getting a decimal, and the decimal here is not an integer. I'm sure you've understood as to why division doesn't follow the closure property, right? So out of all the 3 operations, addition, subtraction, multiplication, and division, it's only the division that doesn't follow the closure. Okay, now let's move on. Again, property of commutativity also doesn't apply to division. Take some numbers, check it out yourself. Let's say 10 divided by 2 is not going to be equal to 2 divided by 10, because 10 divided by 2 is going to be 5, and 2 divided by 10 is going to be 0.2 once you make the calculations. Okay, so all right, it can be no, it can't be a decimal, Gargi. Let me make this very clear. Commutativity, okay, closure is one integer divided by another integer. The result should be an integer every time if division follows closure. But as you've seen, it will not be an integer in some case, right? Coming back to closure again, one integer, when you divide it by another integer, the result is not always equal to an integer. That's the reason why we say division does not follow closure. Okay, yes. Cool. Again, commutativity doesn't apply. In a similar way, fairly simple to understand that associativity will also not apply. And then last thing is division by 1. Any integer divided by 1 is going to result in the same integer. You know, you remember we did the same thing for addition. Like addition, when you add 0, the result is same. A multiplied with 1, the result is the same. In a similar way, A divided by 1, what is it? Is it 1 or A? Is it 1 or A? It has to be A. I wanted to see how many of you are focusing here, and they will point out this mistake here. Look, 5 divided by 1, how much is it? It is 5. All right. Yes, it has to be A. We purposely, let that happen to see how many of you will be able to notice that. So A, when you divide by 1, the result is going to be A. All right. So this was again a fairly simple one. Now moving on from this. All right, let's take a deep breath. Okay, I mostly need this one here. All right, so we have homework time, which means all of the concepts from the topic of integers were revised today, and I'm sure you guys were able to retain it because there'll be plenty of quizzes coming your way, so we just wanted to make sure that all of you had a good revision. So let's check out a homework problem. All right, so here is the question. Solve the following expression. So multiplication is what you have to do here, and let us know the correct option in the comment section below. There are 4 options, and I'm sure you guys will figure out the correct answer to this. All right, so homework question is pretty clear. 4 multiplied with -5 multiplied with 3 multiplied with 6. So this should be fairly simple. Okay, order in which you multiply doesn't matter. First take care of the multiplication and then take care of the sign. Okay, so shall we move on now? I'm sure you guys have captured this as well. Now the next thing is, of course, as you guys know that we have a Telegram channel exclusively for you. Why should you be joining the Telegram channel? First thing is there will be plenty of revision questions segregated as per the topics thrown your way, and then there will be session notes. Okay, all of the session where I have solved it. Okay, you will get the file with the annotations. Sunday fun day facts, like I gave you the one about Bluetooth today, right? So you will get similar fun facts as well, which are good for your knowledge. And then homework questions, plenty of quizzes, and this is pretty important, all the session updates as well. So make sure you join our Telegram channel, and please make sure you subscribe to the channel as well. All right, the link is there in the description box for you. Of course, you know this, we've got you covered, nothing to worry. And then there is going to be a mega quiz for all the 3 grades combined. That's the reason why the revision was there. This is the time, 11th May, 4 p.m. Make sure you guys are there. Yes, Pranjali says, will you send the notes on the Telegram channel? Yes, we will, of course, send you the notes. And then please make sure of this trial class, guys, because this is absolutely free. The link is there in the description box. Make use of it. Okay, you get to know how students are taught here, personalized attention, all of that. You'll come to know when you take up the trial class. And then lastly, before I say goodbye, if you like the content that we've provided, make sure you like the video. In case you feel some of your friends or, brothers, sisters, cousins, whoever they are, will find this video helpful, do share this video with them. And as I said, in case you haven't subscribed to the channel, make sure you have. All right, so that's it from my side today. I'm sure, I hope this session was useful. You were able to revise all the important concepts that you've covered before. So make sure you revise this again, practice some questions, and be ready for the Menti quiz that is going to happen on Wednesday. Till that time, take care of yourself. Thank you for your time. Bye-bye.